Okay. Good morning, everyone. So how did the homework go? Did you guys do the practice problems? Any questions from them? Remember, the practice problems are crucial. You have to do them to really learn the material. Okay? Put your question on chat if you have them. All right. So probably some of you know that I graded your quiz and it's already on Brightspace. And every time I grade the quiz, there is a lot of feedback written on the quiz. So it's crucial for you to go and read the feedback and figure out what did you do wrong. That's the only way you're going to learn the material. There was some struggle with problem number 1, so I will read it again and try to make sure you guys get it. So problem number 1 was the following. Let A be all women, all possible women. And yes, Esmeralda. And F the function that to each woman assign the number of children she has given birth to who were alive on January 2020. For each item below, indicate the type of object that the item is. So first let us understand what this function do. So this function is, it is signed to each woman. So it takes a woman in, that's a woman, and it is signed to it, that's what F does, it signs to it the number of children that she gave birth to. Okay, that's really what it does. So what does this function do? So if you take any woman, this function does something to it. That's what it is. So if I take, for example, I'm usually taking people that we all know. So it means if I take F of Michelle Obama, that's the woman. What F does to it, it tells me the number of children who are alive. And we know, or if you don't, she has 2 daughters. So that's really what the picture is. Okay, so it takes in the woman, it spits out how many children they have. It could be 0. It means the woman has no children. So that's really what this function is doing. So now it means this is my input. That's my input. And F of it is the number of children. So when I was asking what type of object is F of C, means so F of C here, this C here is a symbol for a woman. And F of C is the output that corresponds to the woman C. So F of C is the number of children because that's the output. So this is the number of children that women, sorry. So it's the number of children of woman C that the woman C. So C is a symbol that represents any woman. And F of C is the number of children that this woman C were alive in 2015 or whatever, 2020. Okay, that's really the idea here. So this is the input and this is the output. And C is a symbol. So I cannot, if I'm describing the function, I cannot tell you what F does for every woman. So we use symbolism. So F of C, that's really the number. Now part B was, if F of C is D, what type of object is C? C is the input. So C is a person or a woman. That's really the answer to this question. That's the one you struggled with. So draw this little picture for yourself to start interacting with function. So you're given it a woman, it spits out the number of children. F of C, the C inside, that's the woman. And the F of it is the output, which is the number of children. Okay? Questions before we proceed? All right, so this is for the rest was fine. There is one question you had trouble with, but I'm going to incorporate it as part of today's notes. All right, so one of your classmates is asking about problem 1, 2, and 3. Okay, so I will pick, I start with number 1. Now I know she's asking F, but we will go through it. And then we move to number 3. So number 1. So we have this function, f of x equal. So this is a rule. You give it x, and it spits out x squared plus 5x plus c. Plus 6. Okay, so this is a rule. So it means you have a function. You give it an input x, and it gives us something. It gives me whatever. So you give it x, it does something to it. So x is a symbol for every number. And it's going to give me whatever you give it, square plus 5x plus 6. So that's really my function. And of course, when x changes, to take different value, the output here is going to change. All right, so we will do several questions, the one that I know that you may have problem with. So the first one is, for example, easy. What is f of 4? Means if you give it 4, what this is going to give you. So that's simple. It's 4 squared plus 5 times 4 plus 6. It means 16 plus 20 plus 6, which should give me just a simple 42. Okay? Now, C, f of 1/2. And as you realize on your quiz, I want you to express this as usually one fraction. So I don't want you to use decimal if I tell you one fraction, and I don't want you to use mixed fraction. Okay, so mixed fraction, I don't want you to use, but they are not the right way in math, and I want you to avoid decimal. So f of 1/2 is, what does f do? Whatever you give it, it's going to square it plus 5 times 1/2 plus 6. Okay, now we're going to factor. 1/2 square, it means 1/2 times 1/2. And when we reviewed fraction last time, we multiply the numerator over product of the denominator. 5 times 1/2, it means 5 halves plus 6. And now common denominator, which is 4, is 4 here. So it's 1 over 4 plus 5, 2. If the common denominator is 4, I have to multiply 2 by 2 to get a 4. So I have to multiply the top by 2. 6, it's 1 in here. So I have to multiply this by 4 and the numerator by 4. And now this is the end of that. So it's going to give me a denominator of 4. I will have 1 from here and a 10 and a 24. And usually I do stupid mistake, but this should be 35 over 4. Okay. All right. Now, as I said, I will D. D is very similar to something I gave you on the quiz, but it's harder in this problem. And let's do it. So I'll take a nice piece of paper and we will do that. And then I will address the mistake that I saw on your quiz. So D is, they want us to find an expression of f of t plus 2. Okay. Now, first, this is a t. You cannot give it a value. So at this stage, the goal of those problems is actually to help us learn how to deal with functions symbolically, which is absolutely crucial for us. So plugging in number is not really hard, but symbolically how we deal with the function. All right. The rule is the following. What f does is, whatever you give it, it's squared plus 5 what you give it plus c. So f of t plus 2 is, okay, I put this. F will square whatever you give it plus 5 multiplied by what you're going to give it plus 6. Okay, so that's first the setup. Now, we want to simplify. And let me comment on the mistake that it was prevalent yesterday when I graded your quiz. Okay. What is it very wrong is the following. I hope I won't see this mistake again. Okay, you don't have to write, just listen. When I was grading your quiz yesterday, that was a very prominent mistake. A lot of students did that. They took the quantity t plus 2 square, and what they did is they squared the 2, they add to it 2 square, and they gave me t squared plus 4. This is absolutely false. Absolutely false. You cannot square this plus square that. Let us see why. Not because I said so. What does it mean 2 plus 2 square? It means it's 2 plus 2. Basically, you multiply it by 2 plus 2. That's the way I want you to look at it. But this is going to give me what? If I distribute, what do we get? T times t square plus 2t plus 2t plus 4. So it's definitely not t squared plus 1. So basically it means this is t squared. If I combine those two, I get 4t plus 4. Okay? So in general, not in general, I mean most of the time, this is the thing. If you take, so before I go back to the problem, the idea is this. If you take two numbers, you add them, let I call those numbers a plus b, and you square. This is not, it's not a squared plus b squared. You cannot split it this way. This is absolutely false. You can't split this way. A plus b squared is a plus b times a plus b, and then you multiply out. You have to multiply out. It means a squared plus ab plus ab plus b squared. It means a squared plus 2ab plus b squared. Some students memorize this in general. So a plus b squared is equal to that. So it was a very common mistake yesterday. A lot of you actually wrote this, which is absolutely false. Okay? All right. So after saying that, f of t plus 2 should be is much simpler now. So what's f of t plus 2? Again, try to be slow. This is squared. I'll do it one more time. It means this time that. Okay, so. And t plus 2. It's going to give me t squared plus 2t. So again, I'm redoing the problem. Plus 2t plus 4 plus 5 times t. Now I distribute. And when you distribute everything. Plus 5 times 2 plus 6. Okay? Now the rest is to combine term. T squared cannot be combined with anything. I keep it. 2t plus 2t, that's a 4t, plus a 5t, that's going to give me 9t. And then 4 and 10 and 6 give me a 20. Okay? So it's a simple problem. We need to learn how to work with functions symbolically, and that's really the idea here. Okay. All right, so E and F. Again, E. Okay, again, we're working with them symbolically in those two questions. They want me to evaluate and simplify f of something like 2 over y. Okay, and yeah, I don't want you to be afraid of that. So f of 2 over y equal. All right, I want you to do the following. On a scratch piece of paper, I want you all to do this for me. And then I will gonna call on you and see what you guys have done. Okay, so for 1 minute, I want you to evaluate f of 2 over y on a scratch piece of paper so you guys get the right answer when you copy, and see what you get. And then I'll ask one of you what you got. And I want it to express as one fraction. Get going, you have 1 minute for it. Please, for those who don't have their camera on, please, I'll appreciate it if you put it on. Are we ready? Anybody likes to volunteer, or shall I pick one?
Not sure if I did it right.
I don't care. I just want you to do it.
6y squared plus 10y plus 4 divided
6y
by
squared.
y squared.
Repeat. You're gonna guide me through your work verbatim. Okay?
So I have 2 divided by y squared plus 5 times 2 over y plus 6.
Okay. Set up correct. Now the algebra. Very slowly. Keep going.
Oh, the next would be 4 over y squared.
Okay. Do you agree with him? 4 over y squared. Because remember, 2 over y squared is 2 over y times 2 over y. How we multiply fraction? We multiply the numerator over the denominator. Okay, very good, you're fine. Plus, keep going.
Plus 10y, or 10 over y, I mean.
10 over y, absolutely correct. Plus 6. Keep going.
In the next case, you would square the 10 to equalize the denominator. In the second piece, and you would multiply 6 by y squared to have all the denominators the same.
Okay, so you're doing common denominator, right?
Yeah.
So common denominator is, what's the common denominator?
Y squared.
Y squared, absolutely. So now we're doing the common denominator. We have y here and y squared, but y squared will be the common because y squared multiply y. It's just y times y. So it's going to be equal to. This is 4y squared. We're safe. Okay, now, what do you want me to do here?
10 squared over y squared?
No.
Oh.
No. Why? Why? If the common denominator is y squared, it means this has to be multiplied by what to get the y squared?
Y.
By y. Means what should you multiply the numerator by?
By Y as
By
well.
y. Okay, now you don't change the value of your fraction. Are you with me?
Yeah.
Plus.
Plus 6y squared.
Now 6y squared over y squared. Now I am safe. My denominator is actually the same because y times y is the y squared, and that's become the 10y plus the 6y squared over the y squared. Now I have a common denominator of y squared, so I can combine the numerators. It's a 4 plus the 10y plus the 6y squared. Okay. Please go over that again. You have to internalize how to work with functions symbolically, and at the same time, you're practicing your algebra. So it's really doing two things at once. Anybody was able to get that answer? Anybody? No? Somebody?
I got it.
Okay, anybody else? All right. Now the last questions. And so if I flip the page and you guys are not done yet, please let me know, okay? Now here's my question. The question is f. Okay. My function is always the same. So this is my function. I keep it in red here. So otherwise we lose it. So my function, whatever the input is, that's what it does. It squares it, and then it adds 5x to it, and then it adds 6. That's really what this function does. Now, a question f is, find all the number c such that have the following property. F takes those number to the number 42. Okay? That's what the question is. First, let us understand what are they asking us for. F is a function. It takes an input x, spits out the output. The output is given by this rule. The question is, I want to find all the c's, all numbers, such that f of c equal to 42. So 42 in this case is an input or an output value. Back to you.
An output
Danielle.
value?
What?
Oh, it would be an output value.
Right. So this is my 42 right here, basic, if you think about it as function. And my question is, what should I put here? That's the question. What should I put here so the f of c will be equal 42? So how do we solve those problems? So basically, we're going to say, okay, I'm going to look for the c. So we're going to set equal to 42 and solve for c. Okay, because now what I want here is, what should I put here? Which number I should put here so that when I evaluate that, I will get 42. Okay, which number c I should put here so when I evaluate it, I get 42. So the way we do that, we say, okay, I set c squared plus 4c plus 6 because they use the letter c. That's why I'm using the letter c. And I try to solve for c. So the question is how to solve for c. This is actually what's going to be also my topic today, how to solve those equations. All right, if you look at this, of course, I'm reminding you, that's a quadratic. It means you have c squared. The way we solve this is we rewrite, so we only have a 0 on one side. All right, that's the first step. So we're going to manipulate, so we have a 0, only 0 in one side. And then we're going to factor out. To be able to create only a 0 in one side, what shall I do? I should subtract 42 from both. So we're going to subtract 42. The goal is to have only 0 on one side. So if I subtract 42, what will I get? C squared plus 6 minus 42 equal to 0. Okay? So that's whenever it's a quadratic desktop approach you will do. So it means C squared plus 5C. Now 6 minus 42 will give me how much? So you take 2 and then you take 4 minus, I'm at 36. Okay. Then what do we do after that?
We would factor.
Then we factor, exactly. When we're gonna factor, okay? So we're gonna factor. So whenever we have squared, the way to solve is we rewrite, so I only have 0 in one side. It's crucial. Once I guarantee this 1, 0, then I try to factor. That's how we're gonna solve those problems. Now let us factor. That's a C and that's a C. So I'm gonna look for two numbers. When you multiply them, you get minus 36. And when you add them, you get 5. What are those numbers? Anybody can help?
I got -4 and +9.
Plus 9, yeah, because 4 and 9, because the other number are 6 times 6, which is impossible. 12 times 3, it doesn't work. 4 and 9 definitely look -4. So whenever you have a quadratic, I mean, it means there is C squared, and I need to solve. First, we make it equal to 0 by basically subtracting 42. Once we do that, we factor. And now what's the benefit of factoring? The benefit of factoring is the following. Let's see why we factor. If I give you two numbers, A and B, two numbers, and I tell you this is equal to 0, how can the product of two numbers to be 0? When you multiply two numbers, how this is possible could be 0? The only way this could be 0 if one is A is 0 or B is 0. That's the only way when you multiply numbers you can get 0. So when I take this and I said this is equal to 0, the only way this can happen, it means that either C minus 4 equal to 0, that's the only way this product could be 0, or C plus 9 equal to 0. The first one will give me C equal to 4. The second will give me C equal to -9. Okay, so these are the two values of C. How can I check? So these are the values. So the values are C equal to 4, C equal to -9. Those are the values that we're interested in. Okay, back to you. How can I check that my answer is correct? How can I check that 4 and -9 are correct? What am I looking for?
Couldn't you plug them into the equation?
Yeah, which equation? Yeah.
Yeah, plug them in for C, the C squared plus 5C.
Right. So the question is, if I plug in 4 here, do I get 42? If I do, 4 is correct. So actually we've done this. If I plug 4 here, I will get, let me check. I'm gonna check. I'm gonna check slowly. Now it's checking. I wanna compute f of 4. I think we've done it, but we're gonna do it again. What's f of 4? It's 4 squared plus 5 times 4 plus 6. It means 16 plus 20 plus 6. With 6 and 6, that's it, 2, which is 42. So f of 4, my first answer is correct. That's really what I'm looking for. And then what about my second? Is it correct? This is -9 squared plus 5 times -9 plus 6. So now I'm just checking that I'm finding the right input. That's 81 minus 45 plus 6. Now this is equal to, now you can take your calculator if you want, or you can do it in your head, I don't care. Minus 45 plus 6, and that's honest to goodness 42. So my answer are correct. So both input, 4 and -9, will give me an output of 42. Okay. So that's the case totally of number 1. Number 2 is verbatim the same, and I'm going to assign it again because I definitely want you to be able to deal with functions in a very abstract way. Now I look at number 3 because I assigned, because it's a good problem to learn how to work with fraction. And that's why I assigned number 3. So I have a function f. Takes an input x and assign to it x over x minus 6. Okay, so it's kind of harder function. So you give it an input, whatever you give it, and it just, it's like a machine, it spits something. It spits x over x minus 6. That's what f is doing. As of course, as the input changes, your output changes. All right, so we're going to answer some questions. F of 4. So here I'm inputting 4 because that's between the parentheses. What the function do to it? It's 4 over 4 minus 6, which is 4 over negative 2, which is minus 2. B, f of 1/2. All right. Because this deals with fraction and some of us have difficulties with that, I will give you a minute to interact with that one. And then I'm going to address you. So do it on a scratch piece of paper so we will do the neat stuff together. So I want to give you a minute to interact with it because it's a fraction. The first one was fairly easy. And see what you get. And then we go from there. Okay, are we ready? Okay, I'm gonna pick. Drew, did you do it?
Not yet. Sorry, I just sat down. I had to grab my glasses. If you can give me like 2 minutes, I can do it.
No, I can't do that. Sage, have you done it?
Yes.
Okay, guide me through it.
So you plug in the 1/2 for x, obviously, and then the first step I did was to figure out the 1/2 minus 6. So
Very
to get
good. So it's a half minus 6 down here.
Mhm.
Please keep going.
So I turned the 6 into 12 over 2 to get a common
Yeah.
denominator.
So what she did is, that's a half. This is ugly, of course. And I don't want you to use decimals because we have to learn how to work with fraction. Believe me that once you hit calculus, if you guys are going to do it, you will work more with fraction. So what she did was half, absolutely correct. And then she find a common denominator here. So she does this, half minus. So she left the numerator, this right here, it became, so the common denominator is 2. So she multiplied 6 by 2, giving her 12. Absolutely correct. Please keep going.
So then you get 1/2 over negative 11 over 2.
Very good. So now the numerator is not touching it. Now the denominator, it's a half minus 12. I have the same denominator to combine the numerator. 1 minus that would give me minus 11, over 2. Okay, so how she dealt with it? She had the numerator was a fraction and the denominator was. So to be able to manipulate, half is a half. She can't do anything about it. So she made the denominator as one fraction by finding a common denominator. After that, I'm still listening. Keep going.
After that, you'd flip
Right. That's a
and
fraction.
turn. Yeah, you flip it so instead of so you multiply the 1/2 by -2/11.
Exactly. -2/11. Now, the rules of fraction, 1 divided by another. And this should give me how much?
I got -11.
Negative, are you sure 11?
No, not 11. -1/11, sorry.
Exactly. So she simplified the 2 and the 2 because she can do that. And then you're left with 1 here, 11 down here, and of the problem. Okay. So when I'm asking you to do it, to give me the answer as one fraction, that's exactly what I want. I don't want you to do with decimal. It means I don't want you just to plug it into your calculator because I know you can do that. I want you to be able to do the algebra slowly. Please ask questions as we proceed. So now part C, what is C? F of t minus 1. So now we're working with it symbolically. You cannot substitute a number for t. You have to work with it symbolically. So, okay, this is only need 30 seconds. So I'll let you do it and then I will pick up one of you and tell me what you got.
Could you write the formula for
Of course. Yes. I forgot, didn't I? Thank you. Okay. Olivia, ready?
Yeah, I'm ready.
Go for it.
So I just plugged in the t minus 1 first. So I got f of t minus 1 equals t minus 1 over t minus 1 minus 6.
And the denominator become?
T minus 7.
T minus 7. Don't be afraid. Okay, done. That's all you can do. That's it. We're done in this problem. Nothing. You cannot do anything anymore. Okay. All right. I will do E. I mean, you will do E, but and then I will see what you guys have done. It's f of 2 over y. So as I said, the goal of those problems is basically to work with function and to practice at the same time fraction. So that's really my goal behind those problems. Okay, I'll give you a minute to do that. Be very careful because this should remind you the B part. This should remind you what we did here, but in a symbolic way. Okay. Who feels comfortable before I pick one?
I think I'm ready.
You ready for? Go for it.
Yeah. So we start off with 2y over 2y minus 6. Or 2
I
over
mean-
y 2 over y over 2 over y minus 6.
Okay.
And then we find the common denominator in the denominator, which is y. So 2 minus 6y over y.
Right. So minus 6y over y. I'm one step slower than you. So from here to here, I'm focusing on this piece now because the top part is not problematic. And then I find a common denominator. Your classmate found a common denominator. So it's 2 over y divided by 2 minus 6y over y. Absolutely fine. And now this is equal to what?
And then we flip the denominator to
Right?
multiply.
So that's one fraction divided by another one. So now I can do it as 2 over y multiplied by y over 2 minus 6y. Okay. Now, can we make it a little bit better? Can we simplify term here?
Yeah, we could cancel out the two y's.
We can cancel the y because we have a multiplication here. Because we have multiplication, we can cancel the y. We can only cancel. Let me make this idea clear. How can we cancel? If you have like 2 times 5, for example, over 2 times 7, then we can factor out, which give you 5 over 7. What we cannot do, which is a very, very common mistake, if I have 2 plus 5 over 2 plus, remember that's a plus in here, then there is no way on earth I can simplify. So we can simplify only when we have a product, because actually that's wrong. 2 plus 7 over 2 plus this is going to give me 10 over 9. If you click on your calculator, this is not 5 over 7. So they are totally different numbers. Okay, so we can simplify as long as the numerator is the 2 multiplied. It's a multiple in the numerator, and it's also a multiple or a factor in the denominator. If you have a plus, there is no way you can simplify. So in this case, I have a product. So I can simplify the y. So this would leave me with 2, because it's become a 1 in here, over 2 minus 6y. Very good. Can we simplify a little bit more correctly? Do you think we can simplify a little bit more? What do you think? Anybody?
Yeah, can you divide by 2?
I can divide by 2.
No.
So what do you want me to do? Okay. This is 2. Can I factor out a 2 in the denominator?
Yeah.
I'll be left with 1 minus what?
3y.
3y. Now, can I simplify by 2, numerator and denominator?
Yes, you could
Because
cancel.
it's multiplied. It's multiplied. And this would give me a 1 over 1 minus 3y. End of the problem. Okay? All right. For next time, I'm going to do part F. I'm not going to do it with you. I'm going to assign number 3 part F because I want you to do it, and then I will be ready to work with you next time. What we're going to do today is, again, probably one more review for algebra, basically, and we embed functions into them. So what we're going to do today is the following. I'm still working along the same line, not really changing. We're going to do those type of problem. suppose I have this function f of x, the same function. And I ask you, you don't have to write, I tell you what we're trying to learn. Suppose I ask you, find the value of c such that f of c equal to 4. That's the same problem, this type of problem. How can we do that? It means I want to find what c I should plug in here to give 4. So the question is, how do we solve this equation? All right, so that's really going to be the goal of today. So the goal is to remind you how to solve some equations. So, which is the content of section, I guess, 1.7 in your book. Yeah, so the book called it Developing Algebraic Skill, which is basically developing how to solve some equations. So section 1.7, I will call it more algebraic skill. Right? So, how to solve an equation? There are two types of equations. One type we solve them by putting everything in x in one side. And so I will try to isolate the x in one side and then solve for it. And the other way we solve for equation, like the first one we did in class, is that we try to make one side to be 0 only. So let me see what I'm talking about. I will start with the very, very basic. Suppose the very basic ones that probably you've learned back in, I don't know, middle school, I guess. All right, suppose I start with simple one. I tell you solve the following. 2x plus 6, for example, equal 5x minus 1, all right? Means find the value of x so that this equality holds. So this is the degree of x is 1. So those type of problems, the idea is isolate x. So isolate x, have x in one side. All right, how can I do that? You guys help me out. I need to put everything in x together and all the constant term together. That's what I mean by isolating x. So what do you want me to do?
Subtract 6.
Subtract 6. So I will have 2x is 5x minus 1 minus 6. Okay. It means 2x equal 5x minus 7. And then, remember, I need to isolate my x. So all the x's should be together. Then what do you want me to do?
Subtract 5x.
Subtract 5x. So I will get 2x minus 5x equal minus 7 minus 3x equal minus 7. And then I need to isolate my x. I have to divide by minus 3. So the basic one. So x is minus 7 over minus 3. It means x equal 7 over 3. Okay. So the simplest type of equation you will ever encounter is an equation like this. And to solve this, we try to isolate the x. So we try to put all the x's together, the constant term together, and then we solve for it. So, and that's exactly what we did. Just your classmate moved the 6 here. And then we have to move the 5x so we can isolate, and we get x equal 7/3. So the basic type of equation. Please ask questions as you move on. So today, as I said, we're reviewing equations. So now part 2 is, let me solve the following. It's like the problem I just gave a minute ago. I'll do this on a clean piece of paper. Suppose I tell you to solve the following. X over x minus 6 equal to 4, for example. Okay, it means what should I put here? So I get a 4. And we're not gonna guess, we're gonna solve it. So how do we solve those type of problems? What's bothering you and how can we get rid of it?
We're gonna have to multiply both sides by x minus 6.
Yeah, x minus 6 is problematic. I don't like it. It's in the denominator, and you don't like it either. So the way we're going to do is multiply both sides by x minus 6. The goal is really to get rid of it. So I will have x minus 6 multiplied by x over x. Sorry, this is a multiplication, not x, equal 4 times x minus 6. We have to multiply both. Benefit, since we're multiplying, this will go away. It will leave me with x equal to that. Now I am back to the previous problem, which was easy. But first, I have a 4. So to take care of this, I need to distribute my 4. But I really want to put all the x's together. So that will give me 4x minus 4 times 6, 24. Now, as you realize, I'm really back to the problem we started. So now I'm going to put the x's together. So I subtract x from both sides, which give me minus 3x equal, sorry, my apology, equal minus 24. And then I divide by minus 3. And this will give me x equal minus 24 over minus 3, x equal to 8. Okay, so whenever we have an expression like this and we need to solve it, our first attempt is we don't like the x minus 6, we multiply both by x minus 6. Benefit, I don't have a denominator to deal with. And then after that, we just do it basically simple equation. 4 times x minus 6, I don't know what to deal with it. I multiply this, I multiply by that, I distribute, and then I proceed. So this is a certain type of equation that we may encounter. All right. Now, along the same line. So suppose I tell you to solve the following equation. 2 times the square root of x equal to 5. Okay? Very good. What do you want me to do?
Square x to get it by itself.
Repeat.
Would you want to square x to get rid of the square root?
Not yet. What do you think will be the better
And then
problem?
divide
I
by.
think divide
Right,
by 2.
exactly. We want to isolate the square root of x first to make the problem simple for us. To do that, divide by 2. Okay. So now if I divide by 2, I will have the square root of x equal 5 over 2. Now I am safe. I am safe. I can square both sides. And then I will say, okay, this squared is equal to this one squared. By definition, what's the square root of x squared? Square root of x is basically the number. When you square it, you get x back. So by definition, this is the x itself. Now 5 over 2 squared, we've done this before. It means 5 times 5 over 2 times 5 over 2. It means it's 25 over 4. End of the problem. Okay, so in this case, again, we can isolate the square root of x. Let me ask you a question before I proceed to the last type of equation we're going to solve, which is, I already started it. Let me ask you the following question, and I want an answer. Okay, when I first asked your class, you guys to solve this, one of your classmates told me square both sides. Okay, that's a question, you don't have to write. Square both sides. All right, Suppose I follow what your classmate told me. What should I do? What do we mean by square both sides? It means this square is equal to that square. Am I right? Yes or no? Suppose I follow your classmate, okay? And I do that. Now, this is 25. What's this squared? What's this when you square? What should you get? Back to you guys.
So just 2x.
No, that's
No,
what I'm
wouldn't-
afraid of.
Wouldn't it be just 4x?
It will be 4x. Why it's 4x, not 2x? That's why I'm addressing the subject. You know, don't just do things from memory. Think about it every time. What's this squared? What's the definition of that? It's 2 square root of x times 2 square root of x. Am I correct? That's what squaring means. Okay, so don't just try to always think about it. Whenever you have a power, I want you to do this on the side till it becomes very natural to you. But this is equal to what? It's 2, so it's multiplication. So I can multiply any order I want. The 2 times the 2 will give me the 4. Square root of x times the square root of x. This is going to give me the x. Okay? So if you square both sides, it's all right in this problem, but you have to do the algebra correct. So 2 square root of x is not, you cannot just take the 2 out times x. This is not right. So that's what it is. So this is going to give me 4x. Then x would become, of course, 25 over 4. We should get the same answer regardless. Okay? So I repeat, you can do what your classmate said, but you have to be very careful with the algebra. Now, if I isolate my square root of x, the algebra becomes a little bit easier. I don't have to worry about that. So you can do it either way, but that's really my issue was that I was afraid of that if you square both sides, this is not, you cannot just pull the 2 because the 2 is squared. You cannot just take it out because the 2 is squared and the square root of x is squared. So you can't pull it out and tell me it's 2x because the 2 here is raised to the power 2. So you have 2 2's, not only one of them. Okay, so always go to the side and do the math so you can, that at some point it becomes natural to you what you should do. Okay. Now the last type of equations that we're going to do is the one I started basically with, the one that you seem to have been comfortable with. So here's my problem. So whenever I have x squared in the equation, whenever I have x squared, combination of x squared and x, we do not isolate x anymore. The minute I have x squared and x, the way we do it is usually we make one side 0 and only 0. Whenever x squared is in the picture, that's how we solve it, except in a very simple scenario that I will. So for example, suppose I tell you, okay, let me put it in terms of function. I tell you, let f of x equal, that's a function, x squared minus 3x. So this is a function, all right? And I'm going to put here its graph. It means if I take several values of x and I start plotting them here, so I take, for example, x equal to 0 and I plot it, I get a picture that look like that. That's a parabola. So that's the graph of f. Okay, it means what does it mean, the graph? It means any point here, whatever the input is, let us say the input here, this point is f at this input. So very particular point. All right, now I'm going to ask question. Question number 1 is, Suppose I have this function and I want to find those 2 points. Those two. How can I find those? So I want to find those 2 points. What do you think should be my question to find those 2 points?
Would we just factor the equation and get the zeros?
Yeah, so the question is, find the value of C such that the output is 0. So if I'm interested in those 2 points, it means I'm asking you which are the input that spits out an output of 0. So basically, I want to solve f of C equal to 0. Okay, let's do that. What is f of C? Means I set it equal to 0 and I solve for C. Now back to you. How do I solve?
We factor the C
Factor.
out.
Absolutely. Solving, so this is already equal to 0. It means we have to factor. Solving is really factoring whenever I have something x squared, x cubed. Really factoring is the key idea. So we set it 0, then we factor. Now here C seems to be a common factor, so I'm going to factor my C, and I'll end up with C minus 3 equal to 0. It means either, how can this product 0? So it means that C equal to 0, C minus 3 equal to 0. C equal to 0 is there. This will give me C equal to 3. So in the graph of the function, we knew that because the way I graphed it, this is 0. It means this point here, this is 3, and this is 0. And this point, of course, is 0, 0. Okay, that's really graphically what it means. That's why we solve, so we can understand the graph. Okay, 2 more questions. Suppose I ask you the following question. Find f of 4. What am I asking for now? An output or an input? Because I want this to be no problem. Danielle? Is f of 4, is 4 an input or an output here?
Would there be an input?
Right, because it's between the parentheses. Okay, so what's f of 4? It's 4 squared minus 3 times 4. 16 minus 12, this is equal, oh, it's equal to 4. That's interesting. It doesn't have to be. My mistake. Okay, so graphically, it means if I put this 4, that's really what it means. If this is 4 graphically, and I go up to the graph here, this point right there is 4, the input, and the output happened to be the input. It doesn't have to be, but that's what it is. Okay, just by coincidence. Okay, I thought I changed that. Sorry. All right, now, question is find all values of C such that f of C equal to 4. Now, in this problem, is 4 an input or an output? Danielle?
An output.
Output. So how can I solve this? Help me out.
Just setting it equal to 4?
Right,
Just
set it
equation
equal
equal
to
to
4. Because 4 is an output value. It means I have to say, what values of C, what should I put here to get a 4? Okay? Now, how do we solve that? This is a
Wouldn't
power
you-
of 2. What?
No, go ahead. I didn't mean to interrupt you.
I can't hear you.
I said go ahead. I didn't mean to interrupt you.
Okay, how do I solve this? Whenever c is to the power 2, how do I proceed? I should rewrite it so I have is only 0 in one side. Crucial. And then I factor. So how can I do that? I have to take away a 4 from both sides. Okay, so I repeat, whenever you have c squared and c in the equation, it have to be squared, then you rewrite it so that only 0 is on one side. And then once you do that, then you factor the other term. Now for now, most of them should factor unless I goofed. So let us factor this out. Equals 0. What are the factors? Daniel, stay with me.
Wouldn't it be wouldn't you do like C minus 4 and then C plus 1?
Does it work? I don't know. I usually try. I mean, honestly, that's what I do. Let me see if he's right. C squared plus C minus 4C minus 4. Absolutely correct. It means what are the values of C? If this is 0, it means this is 0 or this is 0. This or that. If C minus 4 equal to 0, my C equal to 4. And this is give me C equal minus 1. So there are two input C's that bring up an output of 4. That's how we're going to solve that. Now, graphically, in this question, so I'm going to draw the graph again here for you. That's the graph. 0, 3. In this particular question, how can I view this graphically? Where is the 4 in this question? Is it on the whole? And where is the 1? Sorry, and where is the minus 1 in this problem? So this 4, is it on the vertical or horizontal axis?
Vertical.
Absolutely, it's right here. That's an output value. And what I was looking for, basically I'm looking, so this is the graph and this is the graph. What I'm asking you is, what's this here? What's the input that's given? And what's this one? That's really what I'm asking you for. This one should be the minus 1. And this one here should be the 4. And that's really one reason we try to learn how to solve this equation so we can understand the function better. Okay? All right. So this will be your homework for next time. In the last few minutes, I have to go back to Moodle. I mean, some of you did connect to Moodle and some didn't. I urge you, your homework is due on Tuesday and you're then running out of time to do it. Okay, so I will share the screen with you and I will show you Moodle. Every one of you, because I know exactly who logged in. I know exactly how long you guys have spent. So I can read Moodle very well. So let me a little bit share it with you for those who haven't started yet. So, okay, where is Moodle for me? Okay, so you guys, I don't know what the site you see, but that's really my site. So I'm gonna go to it. Oh, sorry. Okay, so this is your class. Your class is the green one, I think. Yeah, this is your class, for example. And you will see your homework. Now you may have a interface different than mine. I don't know what exactly you guys see, but that's really, so this is assignment 0. This is the one that assigned for Tuesday. And I'm gonna take a typical problem and show you how really it works. Okay, so I'm gonna take a problem. I can make the screen better, very good. So, okay. I'm gonna take a simple problem. I will let you guys struggle with those. So some of the problem, like I did on the board, I did a lot of problems along those lines. You guys will have to do them. And I'm gonna take a problem, a simple one, something like that. Okay, so let's see how it works. They tell you consider the following expression. Now, of course, I didn't do this on the board verbatim, but this is something that I assigned them for you to review. So the expression is s plus 5 times minus 4s plus 3. Okay, very simple expression. And then they ask you a question. They tell you enter a expanded but not simplified. So here they're asking you basically to multiply out and no, not simplify. So it does multiply out, and I may do some mistakes. So which is okay. I'm going to do some mistakes on purpose. So let's multiply. I get minus 4s squared plus, let us say 3s. Very good. Minus 20s. Am I doing any mistakes so far? Yes or no?
There's an underscore instead of a minus.
Where?
Oh, after 3s minus 20.
What did I do? Oh, sorry. Okay, I'm old, so my vision sometimes get into the picture. And finally, plus 15, right? Should it be plus 15?
Yes.
Yeah.
Okay, I'm gonna put plus 16. Okay, on purpose. I'm doing that on purpose for you. I know it's plus 15. And then they tell me enter a expanded and simplify. So what do they mean by that? It means that they want me to collect like terms. So it's minus 4s squared minus 17s plus, let us say, 60. Okay, I know that we did a mistake. And then save answer. So I'm saving my answer. Let's see what Moodle will do for me. Your answer was interpreted as follows. So they tell me how my answer was interpreted. And so that you make sure that what you've entered is what you want. Is this the answer you wanted to give? If so, click the check answer. If not, then put the cancel and change it. Let us say I didn't pay any attention to what I'm doing. And then I say, okay, save answers. All right, let's see what. So they tell me, your answers are incorrect immediately. You will first comment on your unsimplified answer. Your answer is not correct because it's not equal to the original expression. So now you realize that you're not doing it correctly. Now comment on the simplified answer. Again, they tell me it's not true. So I realize I have something wrong. I'd go and try to fix it. So I say, okay, I want to fix it. I'm going to fix the first one. I'm not going to fix the second. Save answer. Okay. Now they tell me how the answer is interpreted. And then, okay, that's what I want. Okay, now what do they tell me? Your answer is partially correct. We first comment on the one which is not simplified. This is correct. So now I know that my first one is correct. But then they tell me, we now comment on your simplified answer. And this one is not correct. So now you start realizing, okay, I get this part, so I must have messed up in the second one, which is already guiding me. So I go to the second one now, and I probably fix it a little bit. And now save answer. Okay, your answers are correct. Now you have the right to 4 attempts. After that, you cannot do the problem anymore. So my advice to you is you take the problem, you do it on a sheet of paper very clearly, and then you enter your question, your answer. Don't enter them immediately because you will lose your 4 attempts. All right. So that's how it works. And I want you all to log in. I know a lot in this class, a lot of them did, but I have some who didn't. And please start working on the problem. Some are challenging, a bit more challenging than the one we did in class, some of them, but it's okay. It's part of your learning experience. Okay. We only have, now for the Moodle, you have 4 attempts. Esmeralda, what's your question?
I was wondering, okay, so even if we did use the 4 times and we got the question wrong, So we already got like question 1 wrong. And then you got the rest right. Can you go back into the assignment and try to get like
No. Every question has 4 attempts. So if you lose the 4 attempt on this question, you're done.
Okay.
Is that clear?
Yeah.
Okay. So I usually try on a piece of paper, try to do it and see what happened. But after the 4th, then otherwise you will have like 16 attempts, which is almost guess and check by then. Okay. So please, for Tuesday, I want you to do both. I want you to do these practice problems and I want you to do the Moodle problems. Okay. And if you work with me very well, you guys will be fine. If you don't, you won't be fine. All right. So please give it your best shot. For a lot of you, if you're going to go into calculus, it's crucial. For those who just their last math class, you want to get out of it. So please get the work done and you will be fine. And again, for the quiz, read the feedback. Read what I tell you and ask me if you don't understand. That's the only way we can move forward, all of us. Okay. One more last thing, because I let you go. If you have questions with Moodle, you can email me and I can help you out. All right. So feel comfortable to email me because it's the first homework. So if you're struggling with it, let me know. All right. Any questions?
I have a quick question. Where in Brightspace can I find the information on where to get the pick up the
I'll share the screen with you again, so everything will be clear, okay? So if I share the screen, let me go to Brightspace. All right. So are you with me? So on Brightspace, you have online homework. Do you see it?
Yeah.
Click here. Instruction for the online homework. And then you get a document. Can you see the document? Yes or no?
I don't see it on your screen.
You don't? Okay. Why don't you go to Brightspace yourself? Go to your own Brightspace. I thought I shared it with you. I don't know. I will try again to share it, see if it works. Is it sharing or not really?
No.
No? Okay. Go to Brightspace yourself. Are you with me? Go to Brightspace.
Okay.
Online homework. Do you see that?
Yep.
At the bottom of it, it's written instruction for the online homework. Do you read this?
Is this Moodle only? I need to I was asking where to pick up the book, like the.
I thought you're asking me about Moodle.
No, where's the information, what's the time and area I pick it up?
It's on, okay, again, it's also on Brightspace. Actually, basically, it's every day from 9:30 to 3:30. It's in the Hammond campus. And now I forgot the room number. The room number, I think, is 343. It's the secretary. So it's on in the CLO building, my apology. Hammond campus, the CLO building. Room 343. Okay, it's the secretary's office. And at the same time, I have the book on Brightspace. You know about that?
Yeah.
Yeah, I have the book on Brightspace just in case you guys couldn't go there, but you paid for it, so it's yours. So just go between 9:30 and 3:30. Avoid Fridays. Fridays, I don't know if the secretary will stay. Hammond campus, CLO building, number 343. Okay, it's basically the secretary's office, and you go and tell her I am taking, 153 with Professor Elias, and I need the book, and she will give it to you. Okay.
Mm-hmm.
All right. Any other questions? All right. So have a good weekend, and please register to Moodle. Start the homework. If you're struggling, you can email me, and I can help you, via email, and you can come to my office hours. So I have one right now at 11, and I have an office hours in the afternoon. So please use them. I'm sitting here waiting for you. Okay, so I have office hours at 11 o'clock from 11 to 12. So you guys can join me. And I have office hours from 2:30 to 3:30. That's every Tuesday and Thursday. So you can come and you can, ask me questions. It's yours. It's your time. Okay. Bye for now.